Hey, welcome to the RAEN Guide, Rust and Near the Friendly Way. Let's get into it. Go ahead and point your browser to raen.dev/guide. You'll see a nice little intro about why we created this, about the name. Let's get going. It's going to get you set up. Install Rust, add WebAssembly, install RAEN, install Near CLI. Someday RAEN will wrap Near CLI, but for now you need both. Configure your editor. Don't skip it. Gives you superpowers. Clone the examples repository to raen-examples. Inside there's a contracts folder with a counter project inside there. That's what we're going to be looking at in this video. Go ahead and build that. This will install all the dependencies so that your editor can actually give you helpful info, helpful error messages. Great. Next chapter is looking at the code, but we're just going to look at the code together. Here you can see I opened the counter folder, not the near examples folder. Counter is its own Rust workspace for now, so we need to open it in order for Rust Analyzer to give us the helpful info that we want to see. Source/lib.rs is the main file for Rust libraries. You can see some documentation comments at the top, some imports. We'll learn more about those later. For now, let's learn about all of this stuff by seeing how it's used rather than reading the helpful information that shows up on hover. Great. So really the Rust code itself starts with this pub struct counter. This is Rust's type system in action. We're declaring that we have this type, a structure called counter. We could change the name of this. We could use F2 in VS Code and call it contract. This is our main contract after all, so maybe we want to do that. And then inside there, we've got one field, val. This is another variable. You can name it whatever you want. We could call this counter. The contract has a counter. Seems reasonable to me. And it is an I8, an integer, a signed integer with 8 bits. So it can be between -128 and +127. If you need a refresher on how numbers are stored as binary, go search for one. One is linked in the actual RAEN guide if you go read through it. For now, let's move on. Actually, you're probably wondering about all this stuff. Near bind gen, this hash bracket syntax, what's going on? These are called macros. There are a few different types of macros. The other is log with an exclamation mark. If a function has an exclamation mark, that's another kind of macro. So you can see near bind gen twice. Both times that contract shows up on the struct and on the implementation. Implementations are how you add functions, methods to a struct. Cool. Okay, so back to macros. Near bind gen, these hash bracket macros are adding a bunch of extra code, a bunch of boilerplate to your Rust code. So these will expand the definition of the thing that follows. Near bind gen adds all of the bindings. It generates the bindings for near so that your Rust code becomes near Rust code. Good enough for now. Derive is a special macro used to apply derive macros. See the reference for more info. Super handy to have this hover information, isn't it? Default is going to derive a default. You can see in here we never initialize contract. We never set counter to 0, but when we deploy the contract in a little while, you'll see that it defaults to 0. That's thanks to this thing. Borscht, deserialize, Borscht, serialize. Borscht is a serialization standard created by the same people who maintain Near core. It was created because nothing else was good enough back when Near was getting started. Mostly the problem was consistency. You can take some data some objects in your program, represent them as bytes, but with a lot of other serialization standards, there are multiple valid ways to store it as bytes. With Borscht, it's always consistent. You take an object from memory, turn it into bytes. It's the same bytes every time. Take some bytes, turn them back into objects in memory. It's the same objects every time. Great. So we need to derive Borscht serialize and Borscht deserialize so that we can store your contract's data on disk in between calls, right? When someone makes a call to the blockchain, that contract is going to be fetched from storage. It's going to be serialized into memory. It's going to be deserialized from storage into memory. And then whenever the contract is done running, everything gets serialized again, stored back in memory. Great. So that's what's going on with those 1, 2, 3, 4 macros. That's what's going on with pub struct. And now we've got an implementation, so we can add some methods. And here, this is a view method. It takes and self. The and is a reference to self. This is using Rust's borrowing and ownership model. This is a key part of understanding Rust. You need to understand borrowing and ownership. For now, just know that if you see the ampersand, it's borrowed. So this thing can't clean it up from memory. This is part of Rust's zero cost abstractions model. So you don't have to manually manage memory, nor do you have a garbage collector, which is very expensive at runtime. Cool. Okay. So anyway, this is how you do methods in Rust. And self is a reference to this struct. So you can see self.counter here. This method returns an I8 because counter is an I8. So this is returning I8. It might not look like it's returning I8, but there's no semicolon. That means it's returning it. If we add a semicolon, fun times, we'll get an error. The 8-bit signed integer mismatch types. Expected I8 found open close parentheses. The open close parentheses is called an empty tuple in Rust. So that's the default type. If we get rid of that, semicolon again, the error goes away. And if we change this to an empty tuple, we get a different kind of error, kind of the opposite error. Mismatch types. Expected empty tuple, right? Found I8. So you can also do this in Rust. If you have a method that is void, returns nothing, you can just leave the empty tuple off. That's how you do void returns in Rust. All right, so we want to put that back to I8. We should see the errors go away. Great. If you do this, it does work. No one writes Rust this way. Super not idiomatic to put in an explicit return. So get used to seeing the presence and lack of semicolons. That's going to help you out in Rust. All right, view methods. Oh, and FN means function, if you were wondering. Great. View methods. This is a change method. It takes a mutable reference. The reference is the ampersand. Mutable reference to self. Self, again, being our struct. Oh, and pub. I didn't say. Pub means that it's public. Make an item visible to others. So that means it's visible outside of this file. You have to put that on the struct that you are decorating, that you're wrapping with near bind gen. Mutable reference to self for increment. Increment is going to return an I8 again. It takes self.counter, self being the struct contract, counter being the I8, and it adds 1. This is not going to be saved until the function is done being called. So if there's an error somewhere on one of these lines and the contract panics, then counter will not actually be incremented. So we might even get through this log on the next line. Remember, this is also another kind of macro. It's doing some substitution here, putting in the new value of counter. But then if we do something nonsensical on this line, something, or, panic. Oh no. Now this counter value is not going to be saved. We're going to see a log that says that it was increased to 1 or 2, but it's not actually going to be persisted in contract storage, in blockchain storage. All right, cool. And then we are returning self.counter again. You can see it's the same as this line, no semicolon. Great. And then we've got a decrement method, does basically the same thing. Clear enough? All right. Let's deploy it. I'm going to close the sidebar, open my terminal. You can see I'm in RAEN examples contracts counter. I want to RAEN build -- release. RAEN wraps cargo build, so that you could do cargo build -- release. RAEN gives you a couple nice things. One, it's adding other flags that you always need in a near context, like target WASM32 unknown. That means the platform and something are unknown. And it's doing other nice things. It's looking at the comments in your code, the names of the methods in your code, the function signatures, and it is generating a whole interface spec called WIT, if you're wondering what the type of spec is. And it's injecting that into this compiled WASM file. So now we can deploy this. You can use near dev deploy and just give it the name of that /target res counter.wasm. Wonderful. All right, here it goes. Near dev deploy. Well, actually, I want to reopen my sidebar. This near dev folder just appeared. Near dev deploy created this near dev folder. I wanted you to see that. All right, so we've got this contract, account ID, dev - some numbers - some numbers. Cool. Copy that. Oh, new near CLI version available. Let's skip that for now. Copy that. Go to rain.dev/admin. Paste in that contract address that near dev deploy gave you. And look at this. Get num 0. Increment decrement. And you can see public method decrement the counter. That is over here. Public method decrement the counter. If we change that, get rid of public method. Maybe we don't need that. And kids these days, we don't like the period at the end. Who needs that? So I'm going to redeploy that near dev deploy. And instead of doing this in 2 steps, I'm going to do this in 1 step by using command substitution. RAEN build -- release. This had a lot of output, but if you add a -q, it just tells you the location of the file. So you can do nice things like this. So this is going to rebuild in the background and then use the file path that's returned from it and pass it to near dev deploy. Near dev deploy, we'll see that we already have a near dev folder over here, and it will use the credentials stored in that near dev folder to redeploy to the same account. So now if we refresh, decrement the counter, we see the comment change. Great. All right, so we need to sign in. Let's do it. Sign in. And if you haven't used Near Wallet before, you get to create an account. We can do ohno.testnet. Reserve my account ID. Choose a security method. You used to be able to do email and text, but that was not secure. I wish they kept it on testnet because testnet doesn't need to be as secure. Oh well. So I'm going to copy these. I'll change it later so you can't steal my testnet tokens that mean nothing anyway. So you can't take control of this fun little account that I'm creating. My LastPass vault, I've just been pasting these testnet keys into secure notes. So let's go to notes in LastPass, because then I can get them from any device. For a mainnet account, you probably want to use something a little more secure. I've got some stellar pub and private keys. Oh, there's my keys. All right, so we'll call this ohno.testnet in my keys folder, and we will paste that. Save. Does it show it? No, it doesn't show it because I'm not showing the keys folder. Keys folder. Make sure that it's there. Wonderful. All right, say continue. Word number 10. There are 12, 11, 10. Trade. Verify and complete. Creating account. ohno.testnet/verify. Okay, connect with Near. An application is requesting limited access to your Near account. Select the account you wish to connect rain.dev. We are connecting ohno.testnet. Wonderful. This will allow rain.dev to view my address, view my balance, call methods on this specific contract, dev-whatever-whatever. It will only be allowed to spend 1/4 of a near on transaction fees. More info on that in the written guide. Let's go for it. Connect. All right, so now we can decrement the counter. Let's go for it. Hit submit. And let's talk more about these options while that's doing its thing. Oh, look, it already returned. We can view full transaction details on Near Explorer and on Near Blocks. The return value is -1, so if we go back to get num, it is -1. Beautiful. And if we go increment again, we can submit. And we'll see. Near's fast, y'all. Look how fast that was. I mean, for a blockchain, pretty fast. Okay, so return value 0 because we incremented from -1 to 0. Wonderful. All right, ohno.testnet. This is the action called method decrement in contract dev-whatever-whatever. Execution plan, blah, blah, blah. Oops, I accidentally clicked on the contract. Great. All right, and the same thing over here. Looks like it's not loaded in yet. It's out of sync. Some blocks or transactions may not be here yet. Okay, well, glad we saw it in one of them. So what is this attached deposit? Blockchains, programmable money, right? You can attach money, Near tokens, to any call and do the program, the smart contract can do whatever it wants with your tokens, with your money. That's what's great. It's super easy to program new financial instruments. Wonderful. Gas, units in gas. If you want to learn more about gas, go to docs.near.org/docs/concept/gas. Oh, nope, /concept. It doesn't matter. Just search for gas in here. You'll find it. All right, but this is the transaction fees. So every time someone makes a call to a blockchain, the people running the infrastructure of the blockchain incur a little bit of cost. That's accounted for in gas. These are gas units. Generally, a teragas equates to about a millisecond of time. Roughly, that's the way that it's designed. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 30 teragas. So we'd be able to do about 30 milliseconds worth of work. Incrementing a counter takes way less than that. 30 is more than you need. The excess is refunded to you. Don't worry about it too much. The maximum you can attach is 300 teragas. Someday, rain.dev will show much more easily visually parsable gas units and attached deposits. So this is in Yocto Near, which is even more ridiculous than teragas. If you wanted to attach 1 Near, you would have to do 1, that's 1 Yocto. That's 1 over 10 to the 24th. So this is 1 Near. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21. There. That's 1 Near. Yikes. All right, great. So good thing we don't need to worry about those for the counter. All right, so something that I want to look at, though, is we can squint and say, okay, we're creating our own financial instrument. So this is something like a currency. And what happens if we are currently at the limit of what an I-8 can be? It can only go up to 128. What happens if we try to go 127? What happens if we try to go to 128? We could mash increment 128 times. Take not 3 minutes maybe. Not too bad. Can we do it faster? Of course we can do it faster. We can do way better than that. So let's make a method called public method. Sure. Set the counter. We'll just call it set num, and it'll take a new value. It is going to be an I-8, and we say self.counter equals new value. set number 2, self.counter, return counter. Great. And again, if we did something nonsensical, like put in an I16 here, which has 16 bits, then it's going to tell us it expected I8, found I16. Wonderful. If we said that this was a string, obviously that's going to cause problems too. Mismatched types, found struct standard string string. Great. So Rust is watching out for you. It's the most loved language 7 years in a row in the Stack Overflow survey. Amazing. Let's redeploy that. So we'll have a new set number. And almost there. Okay, refresh. Is it there? Increment, decrement, set num. Beautiful. 128. If I try to say 128 because I forgot what it's supposed to be and I say submit, should be less than or equal to 127. Cool. So this is validating the inputs a little bit here in RAEN admin. Submitting, loading, loading, loading. And result. 127. Wonderful. So I can't set it to 128 in here, but I can try to increment it to 128. What happens then? Here we go. I press submit and result negative 128. That is called an overflow. And if we decrement now, this is called an underflow. It goes back to 127. That's obviously wrong. Let's fix this. So if you go into your cargo toml, down here, overflow checks equals true. If you build without -- release, it uses the profile.dev settings. Profile release, we want to change that to true also. And they're opposites. The default for dev is true. The default for release is false. So that's why in this example, we put both in so you can see them both. Great. So now we're going to rebuild. I'm going to show you this time that if I just RAEN build -- release, it takes a while. It's not as fast this time because rather than just building your contract with the new settings, it needs to rebuild all the dependencies with the new settings too. So you can see that it's building all of them. Compiling counter, building 47 of 48. All right. And it's doing a lot. Great. Now I'm going to do the near dev deploy ./target/res/counter.wasm. Still going to 166-557. That's what we've got in here. 166/557. Great. So now if we go back to increment, the new one is there. It's done. And if we try to increment now from 127 to -128, we should see it say, hey, you can't do that. It throws an error. Execution error, smart contract, panicked. This is good. We want it to panic. We don't want it to let you do things that are wrong. Attempt to add with overflow. That's the default error message. Not too bad. Great. Okay, so one more thing. How do we get this to look nicer? We've got this new account name. If we go to wallet.testnet.near.org, we've got ohno.testnet. How do we deploy? This is a named near account. If you're used to other blockchains where a public key is the account name, it's synonymous with the account. Near is better than that. It has these named accounts. They can have multiple keys. You can also do that thing where the public key is the account name. It's called an implicit account. But if you use Near at all, you'll see these named accounts all over the place. And some of them seem to be smart contracts also. What's going on? Well, what is going on is that you can deploy a contract to any account on Near. So we could deploy this counter contract right to ohno.testnet. How do we do that? We'll find out soon. Or we can create sub-accounts. We can create counter.ohno.testnet, and we can deploy this counter to there, leaving ohno.testnet open for more important things. here's how that works. You run near, let me maximize my terminal, clear it, near login. This is going to open wallet.testnet.near.org. And it's going to request a full access key. Ooh, if you want to learn more about full access keys, go read the guide. Unknown app. Be careful with full access keys. Obviously, near CLI, trustworthy. Go ahead. And you are logged in. Please close this window. Okay. Logged in as ono.testnet with public key, So now I can say near create account counter.ono.testnet -- master account. This is the account I'm using to create the sub account. It has to be the parent of the account. ono.testnet. And initial balance. ono.testnet is going to send a little bit of money to counter.ono.testnet. Let's send 2 near. This is near, not Yocto near. 2 near. Account counter.ono.testnet for network testnet was created. Great. Testnet itself, by the way, is a regular account with a special contract deployed to it that makes it easy to make sub-accounts. So ono.testnet is a sub-account of testnet. And anything on mainnet, likewise, is a sub-account of the near account. Someday, new top-level accounts will be created and auctioned off. But for now, on mainnet, you can only create sub-accounts of near. All right, so now we've got counter.ono.testnet. Now we can say near, instead of dev deploy, we just say near deploy counter.ono.testnet, and we give it the path to our WASM file, RAEN build -- release - q. Done deploying. So now we can go back, go to ono counter.ono.testnet. Boom, get num. It's 0. Of course it's 0. We haven't done anything with this yet. We can set the number. Oh, we have to sign in. It's a different contract. So that's one other thing. We added that full access key. What's happening when we sign into an account is that we're adding a function call access key. This is another key thing to understand about near. If you go to your local storage in your web inspector, you can see my key, near API.js key store ono.testnet:/testnet. This is my private key, but it's the private key that's only allowed to spend 1/4 of a near on network transactions, and it's only allowed to call dev dash blah, blah, blah. We're back on dev, although this is saying counter.ono. Oh, right. I never went back. There we go. Okay. So this one's only allowed to call dev dash whatever. If we tried to call another contract with it, it wouldn't even let us. All right. So that is the quick overview. Again, go to raen.dev/guide if you want to learn more. And that's obviously a toy contract, useful for learning some basics about near. The next chapters are going to build incrementally more useful contracts with you, where you actually store different data for each user instead of everyone interacting with the same counter. Great. All right. Thanks for watching. I will see you in the next one.